if I were going to take 522 divided by 3, we would start with how many times does 3 go into 5? It goes in 1 time. 1 times 3 is 3. You subtract, and then bring down the next number. How many times does 3 go into 22? 7 times. 7 times 3 is 21. Subtract. Then you bring the next digit down. How many times does 3 go into 22? 7 times. Yeah, you know, if I could do math. This would be 1. So 12. 3 goes into 12 4 times. 12. And I have no remainder. If you had a remainder, like say we had a remainder of 1, we would have stuck 1 over 3 after it. So you always put the remainder over what you originally divide by. Okay, now let's divide polynomials. Leave yourself a little bit of space up here because this is where the answer is going to be. So I'm going to write 6x to the third minus 19x squared plus 16x minus 4. As you're writing this, you want to check to make sure that there's no missing terms. Like you want to make sure if you start with x to the third, that you have x to the third, x squared, x, and then a number. We're dividing this by x minus 2. Okay, here's the kind of crazy thing. Over here on the left, we only care about the x. The minus 2 just kind of comes along for the ride, but we don't really think about it until the multiplying step comes in. Okay, our first round, we are looking at x times what will give us 6x to the third. So it's kind of like how many times does x go into 6x to the third, but you really want it to be x times this number up top is going to give you 6x to the third. So we need the 6 and we need x squared. Once you figure out what that number is on the top, you're going to multiply that number to both of the things on the left and write the results underneath, just like we did with long division of numbers. So 6x squared times x is 6x to the third. You want these to match. That's kind of your goal. 6x squared times negative 2 is negative 12x squared. And you take this, and just like regular long division, you subtract. Your first term should always cancel. 6x to the third minus 6x to the third, that should give you 0. You don't have to write the 0. On the next one, you need to remember that you are subtracting. So this is negative 19x squared minus a negative 12x squared. What is minus a negative? Plus. So negative 19x squared plus 12x squared would be 7x squared. And then we bring down the next term. We're done with round 1. We now start round 2.
Would it be a negative 7?
Yes. It would be. Negative 19 plus 12. Yes, negative 7x squared. Okay, round 2. We are looking for, this time, x times what will give us negative 7x squared. We need the negative 7. And we need another x. Now we are going to distribute this negative 7x to these two things over on the left and write the result right down here. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. We subtract. Negative 7x squared minus a negative 7x squared, those cancel. 16x minus 14x would give us 2x. Bring down the minus 4. Now we're ready for round 3. This time, x times what will give us 2x? Positive 2. Distribute. 2 times x is 2x. 2 times negative 2 is negative 4. Subtract. 2x minus 2x, those cancel. Negative 4 minus a negative 4, those cancel. Your remainder is 0. If we had had a remainder, we would have put the remainder over x minus 2 and added that on to the end of this. But since our remainder is 0, we don't have a remainder on this problem. So our final answer is 6x squared minus 7x plus 2. If I told you to do x minus 2 times 6x squared minus 7x plus 2, so multiply this thing back in, you would end up with 6x to the third minus 19x squared plus 16x minus 4. So we are undoing this multiplication to get 6x squared minus 7x plus 2. All right, let's move to the second example. What's the biggest difference you see between example 2 and example 1? It's a binomial and a binomial, but we're still starting with x to the third. So since we're starting with x to the third, we need some fillers. That means we have 0x squareds, we have 0 x's, and then a minus 1. You need to have a place filler for each of those exponents. So if you start with x to the third, you still have to have x squared and x and then a number. Put zeros in there where those things are missing. And we're dividing by x minus 1. Okay, round 1. X times what will give us x to the third? X squared. Distribute that. We get x to the third minus 1x squared. Now you don't need to write that minus 1. You could just write minus x squared, but I find that when we're doing this subtraction, it's sometimes easier if you do have that 1 written. X to the third minus x to the third, those cancel. 0 minus a negative 1 would be positive 1x squared. We bring the next term down, even though it's a 0x. And we move on to round 2. X times what is going to give us 1x squared? Plus 1x. 1x times x is 1x squared. 1x times negative 1 is negative 1x. Subtract. These cancel. 0x minus negative 1x is positive 1x. And bring our last term down. Okay, round 3, we are looking for x times what will give us 1x. Oh, 1. A lot of 1s in this problem. 1 times x is 1x. 1 times negative 1 is negative 1. When we subtract, they both cancel, and again, our remainder is 0. So our final answer is the stuff up at the top, x squared plus 1x plus 1. Example 3 is a little bit different because you're dividing by a trinomial instead of dividing by a binomial. We still start this the same way. We've got 2x to the 4th plus 4x to the 3rd minus 5x squared plus 3x minus 2. As I'm writing those, I'm making sure that since we started with x to the 4th, that we have x to the 3rd, x squared, x, and a number. You have to put a placeholder if you're missing any of those. Cannot draw a straight line. We're dividing by x squared plus 2x minus 3. And just like in the others, we really only care about the first part of that. The plus 2x minus 3 will just come along for the ride when we do the distribution of the terms from the top. So, round 1, we still focus on just that first thing. X squared times what will give us 2x to the 4th? We need a 2. What do we need the exponent to be to make x squared turn into x to the 4th? 2. We need 2 more x's. Now distribute to all 3 of these and write all 3 of them underneath. So 2x squared times x squared is 2x to the 4th. 2x squared times 2x is 4x to the 3rd. 2x squared times negative 3 is negative 6x squared. Subtract. First one cancels, as it always should. What happens with our second term? It also cancels. It won't always, but it does in this case. Negative 5x squared minus a negative 6x squared would be positive 1x squared. Typically, you only bring down just the next term. Do you see how this second term canceled, the 4x to the 3rd and the 4x to the 3rd? There's going to be a blank left there, and we're going to move on. Round 2, we will actually be filling in that blank. So x squared times what is 1x squared? Plus 1. Distribute. 1 times x squared is 1x squared. 1 times 2x is 2x. And 1 times negative 3 is negative 3. Do you see this hole that we have in the subtraction problem? Anytime you have a hole, bring down that next number. You don't want to have a hole. You've got something above that you can drop down. Cancels. 1x. And what's this last number going to be? Plus 1. Now we could try to continue. X squared times what is 1x? The problem is we're starting with x squared and we're trying to get to x. We already have too many x's, so it's not possible. Once you get to a point where your exponent on this term at the bottom is smaller than the exponent that you're dividing by, you are done. So our answer is 2x squared plus 1, but we have this remainder. So I write plus 1x plus 1 divided by x squared plus 2x minus 3. So you stick a fraction on the end of that polynomial with your remainder over what you originally divided by. And that would be your answer.